Friends, the search for life beyond Earth is a marathon, not a sprint. While we have made remarkable progress in finding exoplanets, the next phase is characterizing these worlds and looking for signs of life. And this is just the beginning. Understanding the role of land masses and specifically continent is critical piece of this puzzle. Let's proceed and explore this further. Hello everyone and welcome. Today we are embarking on one of the most exciting endeavors of humanity has ever conceived, the search for life beyond Earth. We have made incredible strides in recent years discovering thousands of exoplanets, planets orbiting stars other than our sun. But finding a planet is just the first step. The real challenge and what we are diving into today is understanding which of these distant worlds might actually harbor life. And surprisingly, one of the most crucial piece of this puzzle isn't just finding water or breathable atmosphere, but detecting land, specifically continents. Think about it. When we picture habitable planets, we often imagine lush, water-covered world, and while water is undoubtedly vital, the presence of substantial land masses, continents like our own, might be an even stronger indicator of planets' potential to support complex and potentially detectable life. Over the next 30 minutes or few minutes, we will explore why this seemingly simple feature, that is continent, is so essential in our quest to answer that fundamental question: are we alone in this universe? Let's briefly recap how far we have come. Just a few decades ago, the idea of planets orbiting other stars was largely theoretical. Now, think, think about it. Thanks to the mission like Kepler and TESS, we know that exoplanets are incredibly common. We have identified a diverse range of worlds from scorching hot gas giants to ice rogue planets drifting through interstellar space. Crucially, we have also discovered planets within the habitable zone of their stars, the region where temperatures could theoretically allow liquid water to exist on the surface. This discovery has understandably fueled our hope of finding life. However, simply being in the habitable zone doesn't guarantee habitability. A planet could be entirely covered in deep ocean, lacking the geological and atmospheric processes that land masses can drive. This is where the detection of continents becomes so vital. One of the most significant reasons why continents are crucial for life as we know it lies in the regulation of planet's climate through carbon cycle. On Earth, carbon cycle is complex interplay between atmosphere, ocean, land, and even living organisms. Whether it is rock or continents or erosion plays a key role in this cycle. Rain and chemical reactions break down these rocks, drawing carbon dioxide from the atmosphere and trapping it in the minerals that are eventually transported to the oceans. This process acts as a natural thermostat, preventing the planet from overheating due to runaway greenhouse effect. Subduction, where tectonic plates slides beneath each other, then carries these carbon-rich minerals deep into Earth's mantle. Volcanic activity eventually releases some of this carbon back into the atmosphere as carbon dioxide, completing this cycle. Without the continents and weathering process they facilitate, this crucial mechanism for regulating atmospheric carbon dioxide would be significantly diminished, potentially leading to extreme and uninhabitable temperatures, much like we see on Venus. The existence of continent is often linked to another crucial geological process, which is also known as plate tectonics. Earth's outer layer is broken into several large plates that are constantly moving and interacting. This movement is responsible for a wide range of phenomena, including earthquakes, volcanoes, and the formation of mountains and continents themselves. The plate tectonics plays a vital role in recycling material between Earth's interior and its surface. This process not only contributes to the carbon cycle but also help in generating a magnetic field which shield the planet from harmful solar radiation. While we don't know yet for sure if tectonics is prerequisite for life, many scientists believe it's a significant factor in maintaining a stable and habitable environment over long periods, and the presence of continent could be an indirect indicator of an active and dynamic geological system, potentially included in the overall structure of the planet, including the plate tectonics. Beyond the crucial role in climate regulation, continents may also play a vital role in development of the complex life itself. The transition from simple single-celled organism in the oceans to the diverse multicellular life we see on Earth may have facilitated by unique environments offered by land. The coastal region, with their fluctuating tides and diverse habitats, could have provided evolutionary pressure that spurred the development of new adaptation. Land also offers a greater diversity of ecological niche compared to the completely ocean-covered world. Furthermore, presence of land allows for a accumulation of certain minerals and nutrient that might be less concentrated in a purely aquatic environment. These resources could have been essential for the evolution of more complex biochemistry. While life might still arise in the ocean, the pathways to complex detectable life could be significantly enhanced by the presence of continents. So if detecting continent is so important, how do we actually go about doing it on planets light years away? This is a significant technological hurdle. Unlike detecting atmospheric composition by analyzing the light that passes through or reflect off a planet's atmosphere, directly imaging the surface features of small distant exoplanet is incredibly difficult with our current technology. However, scientists are exploring several indirect methods. One approach involves studying the variation in light reflected from the planet as it rotates. If a planet has a continent with different reflective properties than ocean, this rotation could cause subtle but detectable changes in the overall brightness of the planet. Another promising technique involves analyzing the polarization of light reflected from the planet. Land surface and ocean reflects light in a slightly different ways, and measuring this polarization could potentially reveal the presence of distribution of continents and ocean. Further, space telescopes with their advanced optics and instruments will be crucial in refining these techniques and potentially developing new ways of directly or indirectly map the surface of these exoplanets. The search for life beyond Earth is a marathon, not a sprint. While we have made remarkable progress in finding exoplanets, the next phase characterizing these worlds and looking for signs of life is just going to begin. Understanding the role of landmasses, specifically continent, is a critical piece of this puzzle. Our technology advances, our ability to probe the characteristics of distant world will continue to improve. Missions currently in development and those on the horizon hold the promise of providing us with more detailed information about the surface and the atmosphere of the exoplanets, potentially bringing us closer to the answer that age-old question of whether we are truly alone. So in conclusion, while the presence of liquid water and a suitable atmosphere are undoubtedly important factor in the search for habitable exoplanets. The detection of continents could be an even more powerful indicator of the planet's potential to harbor life, especially complex life that might be detectable across the interstellar distances. From regulating climate through carbon cycle and facilitating geological activities like plate tectonics to potentially providing diverse environments for the evolution of complex organisms, land masses play a fundamental role in shaping a planet's habitability. The challenge for detecting continents on exoplanet is significant, but the potential reward and the discovery of another world teeming with life makes this endeavor incredibly worthwhile. As we continue to explore the vast expanse of the cosmos, the search for these distant lands will undoubtedly be a central focus in our quest to find our place within the universe. So, friends, thanks for joining me today on this fascinating journey. I will see you next time. So, keep looking up until next time, and I will catch you again in the next one. Bye for now.